Kia ora Year 12. In this video I'm going to work through 4 examples that have been causing a little bit of trouble on Dr. Frost Maths. So I'm going to start with ones where we don't have to use the chain rule or the product rule, and gradually we're going to work our way up to some harder ones. So the idea with implicit differentiation is that we want to differentiate with respect to x, but sometimes we have terms that have got a variable that's not x. So we differentiate with respect to that variable, which will usually be y, and then we use the chain rule. So let's start with problem 1. So this curve looks like this. It's a classic implicit setup because it's not a function. You can see that we've got 2 y values for just about every x value, right? So it's a relation between x and y, but it's not a function. So let's have a look at how we can differentiate it. Now this is one where we could, if we wanted to, rewrite it and make y the subject, but then we'd have to deal with a positive or negative branch that we can see from the graph. So it's easier to differentiate implicitly. So differentiating with respect to y, I get 8y, and I have to multiply by dy by dx. This next term differentiates to give me minus 6x squared, and the 6 differentiates to give me 0. The last step is always rearranging to make dy by dx the subject of the equation. And we've got, what have we got here, over 8y, and cleaning that up gives me 3x squared over 4y. So that's the first one done. Now the next one's an exponential, so it's e to the power of y squared minus 4x squared is equal to 1. So you can see that we're going to need to use the chain rule on this, because we've got e to the power of y squared, not y. But again, we've got a nice easy one because the y's are all in this term and the x's are all in this one, so I don't need the product rule. So if we start out like this, e to the y squared minus 4x squared equals 1, and we differentiate this with respect to y, and then we multiply by dy by dx. So this will give me 2y times e to the y squared dy by dx minus 8x equals 0, giving me dy by dx is equal to 8x over 2y e to the y squared, which is 4x over y e to the y squared. Now, for those of you watching who are still not that confident with your chain rule, let's just look at, suppose I'm not, so that's my implicit answer, right, but just a little bit of revision. If I had y equals e to the power of x squared, how do we differentiate that? Well, we can treat that as e to the power of u, where u is equal to x squared. And du by dx is equal to 2x. So by the chain rule, dy by dx is equal to dy by du times du by dx, which will give me, so dy by du is e to the u times 2x, and we now substitute that x squared back in here. Okay, but very quickly with exponentials you won't need to use the u substitution directly, you'll just be able to do that in your head. So that's where this term here came from in that differentiation. Okay, on to question 3. So question 3 is 5xy plus 1 is equal to x to the power of 6. So there's my graph. It's quite a cool graph. And you'll notice that it's got an asymptote at x equals 0. Now this is one where if I were asked to do this in an exam and I didn't get told to use implicit, I wouldn't use implicit. And here's the reason why. This one is a function that we can very easily rewrite in terms of x. So y is equal to what? Well, I get x to the power of 6 minus 1 over 5x, which gives me 1/5 x to the power of 5 minus 1/5 1 over 5x. So why on earth would you do implicit when you could just do this? dy by dx is equal to x to the power of 4 plus 1/5 of x to the negative 2. Okay, so that would be the smart way to do it, but this video is all about implicit, And I'm telling you I want us to practice implicit differentiation on this question. So let's do it the other way, and we're going to notice that the answer looks quite different, even though it's actually the same thing. So we start off with 5xy plus 1 is equal to x to the power of 6. So for the first time we've got a product rule. We'll treat it as 5x here and y here. So we're going to use the product rule. We're going to say it's the derivative of this with respect to x will be 5x times the derivative of this. So uv dash plus vu dash. So 5x times dy by dx plus, what's next? Y times 5. Right, so we leave this and differentiate this. So this is u and this is v. Okay, and then when we differentiate the plus 1 we get 0, and when we differentiate the right hand side we get 6x to the power of 5. So the only new thing in that question is the product rule. Cleaning that up, what do I end up with? Well, I get dy by dx is 6x to the power of 5 minus 5y divided by 5x. So that's my answer using implicit. That's my answer not using implicit. And if you do a little bit of mucking around, you'll see that they're the same thing. Okay, the last question I'm going to do in this video is one that quite a lot of you got wrong. And it's, I think because it's got a trig derivative in it. And it's got an unbelievably cool graph. So here's our graph. This is the relation x cos y minus y is equal to x. And we're going to differentiate that using implicit differentiation. So these are my two factors in my product. So we're going to have here the first x times the derivative of the second, which is going to be negative sine y times dy by dx, plus the other way around, the second cos of y times the derivative of the first, which is 1. And now I move on to the next term, and I differentiate this with respect to x. So it's minus dy by dx is equal to 1. Then I just need to be a little bit careful with collecting up and cleaning up my terms. I get negative x sine y minus 1 times dy by dx is equal to 1 minus cos y. So that gives me a final answer of dy by dx is equal to 1 minus cos y over negative x sine y minus 1. Now in Dr. Frost that was a perfectly okay answer. I think it's a little bit ugly like that. I'd like to factor out the negative 1 here, and that will give me this answer, which is a bit nicer. Cos y minus 1 divided by x sine y plus 1. Okay, so that's all I'm doing in this video. I'll do a more applied problem where you've actually got to find a gradient in a separate video, but I don't want this to go too long. So if you're one of the people who was having trouble with that Dr. Frost exercise, can you just go back in when you get a chance and try and clean it up so that you're getting 90 or 100%. Thanks for watching.